FIDO consists of two core operations. The first one, the registration, where the FIDO credentials are created. And the second one, the authentication, where the FIDO credentials are used. Let's begin by discussing the details of the registration. And let's look at this from a flow perspective and the components or pieces that are part of this flow. So the situation is the relying party wants to create a FIDO credential ID. So that is the context. So the way that the RP in the client proceeds is it goes to the FIDO server. It needs to begin by going to the FIDO server because it needs the parameters. So the call to the browser to the client requires to specify how the RP wants this FIDO credential to be created. And the recommendation or what FIDO says is that those parameters need to come from the server. And FIDO calls those options. And in the case of the registration is creation options. So the FIDO server is going to collect or make these options back. And one of the parameters is called challenge. The challenge is a random string. The intention, the purpose is it needs to be useful to avoid replay attacks. So that means that the challenge should be only used once. And the FIDO server needs to be able to detect, has this been used already or not? So that is the purpose of the challenge, as well as as a way to say, yes, everything started from the FIDO server, because the FIDO server should be able to remember or to tell whether it created this challenge. Another parameter is the RP ID, which is nothing but the domain name where the FIDO credentials are going to be created. So this domain is going to be bound to the FIDO credentials. Another parameter, exclude credentials. This is an array of IDs. So the situation is possibly this FIDO server already has FIDO credentials, and typically we don't want to recreate a FIDO credential if there is already one. So the way to prevent that is by including the known FIDO credential IDs in this array as a way to tell the authenticator, hey, if you're familiar or if you know any of these IDs, please don't recreate. Just tell me you cannot create it because I already have this other credential. Another parameter is user verification. This is to decide by the RP whether the FIDO credential requires verification before it is used. This is expressed as this is an enum, so you can specify discouraged, preferred, or required. Another one is the attachment. The attachment is to say, I want this FIDO credential to be on a platform authenticator or on a cross-platform authenticator for roaming authenticators like security keys, or both. So you can, the RP can choose what is the preference. The other another parameter is the algorithm ID. So at the end, the FIDO credential is a public and private key, and during the authentication is used to create a signature, a digital signature, and this algorithm refers to what is the algorithm that wants the RP wants to be used during the authentication. And this algorithm could be based on RSA, on elliptic curve, or Edwards curve. any of those you can choose, and the credential to be created should align to this requested algorithm. So now these parameters, these options are in the RP on the client. The RP is going to pass these options to the client. And by the way, this number 2 is based on the web authents defined by FIDO, so web authent. Then the client is going to actually add its own parameter data. So it's going to pass the options, and it's going to pass something called client data. Something important that is happening here is the enforcement of whether this requested RP ID is valid, because the client, which is typically a browser, knows what is the domain or the origin that is in context right now. And if this RP ID doesn't make sense, then it's going to be not accepted by the client. So that is something that is validated here and actually is kind of reinforced inside this client data. Then the authenticator is going to create the key pair, right? The public and the private key is going to be created. And the authenticator is going to then to respond. Now, what is the data in this response? One of them is an attestation object. And attestation is it includes a signature with the attestation key that belongs to the authenticator. And it's a way for the authenticator to say, hey, I am this authenticator. I'm attesting that I created this FIDO credential. Another parameter is the credential ID. So the key pair is assigned an ID. Another one is the public key. Another one is something called AA GUID, which stands for Authenticator Attestation GUID. This value is an identifier, a unique identifier, not for the individual authenticator, but for the brand and the model of the authenticator. So there will be many different instances of this model that they share the same GUID. Then another one is flags. This is information about the credential that was created. One of the pieces of information that comes inside the flags is whether this FIDO credential can be synchronized or not. So based on the capabilities of the authenticator and the preference expressed in the options, a decision is going to be made, a final decision by the authenticator, and it's expressed in these flags whether the keys will be multi-device keys or it's a single device key. So that is the response. Now, one clarification, right? Because it's possible that people might get confused with so many terms for the following. Registration. Registration also implies creation. So the registration requires creation options. The output of the registration is an attestation. So also this the attestation concept is used to describe this registration process. Now let's go to the next step. So the next step is the RP. So the execution right now is in the RP on the client. Now the intention is, let's send the output from the authenticator to the server, because at the end the server is the one who must have the final say on whether this registration is acceptable or not, right? So a fourth step is, let's invoke a registration API, and let's include all these output that's coming from the authenticator. On the FIDO server, then there's going to be two types of verifications. The first one is regarding the attestation. So let's call this attestation verification. So the first thing that needs to be verified is the actual attestation signature. So the signature from the authenticator is verified, right, using a public key. And then an attestation object typically comes with a certificate chain. So basically, FIDO borrows this concept of certificate chain from PKI, right? And the idea is that on the server, you will need to have something like a trust store. So you need to decide who is it that you trust when they come with a registration. And probably trying to have all the authenticators that are acceptable, it might be too much. So one way how to deal with this is just to have in the trust store the certificate authorities that are accepted, which then issue certificates for authenticators, and then there's a decision whether, because the CA is vouching for this authenticator, I accept it or I don't. So it's a decision that the FIDO server needs to make. Now, during the registration, another aspect is the authenticator, the characteristics of the authenticator. So the FIDO Alliance provides a metadata service, which at the end of the day, you can think about this as a JSON object, and that JSON object is going to include metadata about all the registered authenticators to the FIDO Alliance. So, so let's say that because I need to feel comfortable about the capabilities of the authenticator, in order for me to accept or not the registration, then probably using this AA GUID, I just look up the metadata for this particular authenticator. I can check because obviously there is a schema associated to this metadata. And then you check the characteristics and whatever is important for the context, for the situation, you can check whether the authenticator complies with the expectation of what the FIDO server is expecting, right? So this is the flow for the registration.